All right, so today we're talking about graphing systems of inequalities. So what I put on here is I have the 3 steps to graphing a linear inequality, because you're going to do the same stuff for starters. So step 1 is, if needed, rearrange the inequality so y is on the left side all by itself. This will create the inequality to be in slope-intercept form. Step 2, graph the same way you would graph a line, with one exception. If you have greater than or less than without a bar underneath, you will graph those as dotted lines. Step 3, you will need to shade one side of the graph. Use the y-axis as your determining factor to help you shade, or I can add now, use a test point if that is something you want to do. Read the inequality to determine where you will shade. If it is greater than, shade where the y values are constantly increasing. If it is less than, shade where the y values are constantly decreasing. So today we have a new step. Now, since we're going to be doing a systems of inequalities, we have more than one. So you'll need to shade where they both can be shaded together. So we're going to do a couple of examples so you can get a better idea of what this looks like. Here's also that additional way to find out where to shade, which is called the test point. The test point, you can choose a point called the test point to help you determine where you'll shade. I choose the point 0, 0 if I can. Now, if I can't, then I might have to get creative. But I like to choose that point 0, 0 because it's the easiest mathematically to use. If the test point creates a true statement, shade on that side of the line. If the test point makes a false statement, shade on the opposite side of where the test point is of the line. All right, so the first 2 lines, the inequalities, that we're going to graph is y is less than 3x plus 8 and y is greater than or equal to 4x. So again, I still have to make my coordinate plane here, taking into account where I need to graph. So I've got 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, oops, 8, 9, 10, 1, 2, 3, 4, 5, 6. Okay, so going on this pink line, the reason why I had to add more to my graph, as I realized, my equation up here is y is less than 3x plus 8. Now this is telling me I'm going to have a dotted line. Thinking of mx plus b, my b value or my y-intercept is 1, 2, 3, 4, 5, 6, 7, 8, which is why I had to add points. So to graph it, I need to go, then my slope, up 3 to the right 1 or down 3 to the left 1. I can go in that direction as well. And I'm forming a dotted line. Now, with this line, so again, I can take 2 methods here. I can either take how Ms. Maxter had talked about it, which is looking at this y-axis and determining where is y getting smaller. Is y going to get smaller going up here, or is y going to get smaller going down here? Which placement is y going to get smaller? Well, hopefully you can see y is getting smaller here. Or I can choose a test point, and I can choose a point of 0, 0 for this one, which would give me 0 is less than 3 times 0 plus 8. So 0 is thus less than 8. And this is my test point. Is 0 less than 8? Yeah, it is. So that means I'm going to be shading this way. Now here's how I like to do this. I like to go ahead and put little arrows so I know the direction I'm going to be shading in, because I'm not done with my graph yet. Some people will tell you to shade lightly at this, and then when it gets really, really dark is where it combines. A lot of varieties out there. Take your pick, okay? So then my blue one is y is greater than 4x. Well, that means my y-intercept is at 0, 0. So I'm going to put a point at 0, 0. Then I'm going to go up 4, 1, 2, 3, 4 to the right 1. All right? So now I'm going to draw that line. Now, again, that one's a solid line because of this right here, the greater than or equal to. So I'm going to form this solid line. And eventually they are going to cross since they do not have the same slope. So now I need to determine which side do I shade on. Well, I'm going to use the Ms. Maxter way because I'm looking here compared to here. So this side of my line compared to this side of my line. And I'm asking myself, where is y getting bigger? Okay, well, y is getting smaller if I do this. It's just constantly getting bigger negative numbers, but that's smaller in value. So y is increasing here, so I'm going to shade on this side. So I'm shading that way. So that means for this actual systems of equations to shade, I'm going to shade in between these two lines. That's solving the systems of inequalities. I have now shaded between these two lines. And I know on the iPad, maybe it's not as obvious as on your paper, but you're thus shading in between the two lines. Let's try another example. All right, so now my equations are y is less than or equal to 2x minus 7, and y is greater than or equal to 2x plus 7. So I'm going to need a big graph on this. I'm going to need a lot of room, okay? So here I go down, need a lot of y. All right. So I need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I am going to graph my pink line first, remembering I graph the y-intercept first, which is at negative 7. 1, 2, 3, 4, 5, 6, 7. I'm going to plot a point there. My slope is a positive 2, so I'm going to go up 2 to the right 1. Up 2 to the right 1. I get to draw a solid line because it was the equals. All right. And now I need to determine which side am I shading on. So again, I go back up here and I look at this, or I can choose a test point. Well, I'm totally free to choose a test point of 0, 0 if you would like to. So I'm going to plug in a 0 for y and a 0 for x. And I get, is 0 less than or equal to negative 7? No, 0 is not less than or equal to 7. So that means I'm going to be shading, or the negative 7, I'm going to be shading this direction. But I don't want to commit yet because I want to graph my other line before I make my committing. Okay, so now I'm going to graph the blue line, which is 1, 2, 3, 4, 5, 6, 7. And look, my slope is the same. 1, 2 to the right 1, 1, 2 to the right 1. And again, it's a solid line because of the bar underneath it. So now I need to determine where am I shading here. So again, on this one, I'll use the Miss Maxter method. But you can use a test point, and I would still use the point 0, 0 because that works out really, really nicely. Miss Maxter method says if y is greater than this, where is y getting bigger? Is y getting bigger up top, or is y getting bigger down here? Well, y is getting bigger this way. Okay, and you can see it if you plugged in a test point 0, 0, you get 2 times 0 plus 7. So 0 is greater than or equal to 7. Well, that doesn't make any sense. You know that. So that means I'm shading this way. Well, now I can just shade because I'm shading in the opposite directions. So I'm shading this way for this graph and this way for this graph, and I'm done. I've shaded. So I didn't shade in between this time. I shaded in the opposite directions. All right, so we're going to do another example. So this example says 2x plus y is less than or equal to 5, and 2x plus y is greater than or equal to 7. So the equations look very, very similar, but I'm going to go ahead and solve them both for y so I can play the game a little bit easier. And when I do so, I get negative 2x plus 5 on this side because I simply just move the 2x to the other side. And this one I get negative 2x plus 7 because I simply just move that 2x to the other side. So I'm going to graph these. So it means I need to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So when I'm graphing the pink, I go up 5 and I put a point. And then I'm going to go down 2 to the right 1. Down 2 to the right 1. And I have a bar underneath it, so it's a solid line. And the blue one, I'm going to start at 7. And I'm also going to go down 2 to the right 1. So my slope is the same, which means these are parallel lines. Now, we're not finding a solution in the sense before. If these were equal, we would then say no solution. But there is a solution here. So now we have to determine where each of these are going to shade. Now the joy is on each of these I can pick that 0, 0 point. I can pick this point right here in the middle because it is good to go. So when I do so, I get 0 is less than or equal to, negative 2 times 0, 0's out. 0 is less than or equal to 5. Well, is 0 less than or equal to 5? Yep, so I'm going to shade in that direction. When I do my blue point over here, if I plug in 0 is greater than or equal to, negative 2 times 0 is 0. So is 0 greater than or equal to 7? Nope. So I need to shade in the opposite of that test point and going that way. So this one's another example where we're shading in the opposites. Just happen to be. Okay, so we're shading on the outsides, not in between the two lines. All right, so we'll do a fourth example here. So the fourth example, we have 3x minus y is greater than or equal to negative 1. And we have 2x plus y is greater than or equal to 5. So I'll start with the pink, because I got to do some rearranging before I can do stuff with this. So again, this one's a little bit more work, because I'm going to need to subtract 3x from both sides. So I'd have negative y is greater than or equal to negative 3x minus 1. But I want to divide everything by negative 1. Now remember, when I'm dividing or multiplying by a negative of an inequality, my inequality sign changes. So now I'm going to have y is less than or equal to 3x plus 1. So notice I changed my inequality right here. This flipped because I divided or multiplied by a negative. Over here, it's a lot easier. I just need to move that 2x to the other side, and I get negative 2x plus 5. Okay, so now I've got to graph these. Yeah, I'm good there. So I just need to make sure I go up at least 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I'm going to graph the pink one first. With the pink one, I go up 1, plot a point. Again, the bar is there, so I'm doing a solid line. I'm going to go up 3 from that point to the right 1. Up 3 to the right 1. And draw my line. Okay. Now the blue line, I need to go up 5. 1, 2, 3, 4, 5. And now I'm going to go down 2 to the right 1. Down 2 to the right 1. And draw my line there. Okay, so now I have 2 lines. 2 lines. Well, I got to determine which, probably what's going to happen is, which of these sections is my mutual shading going to happen. So we're going to start with the pink one here. I can totally choose that 0, 0 point, if that works for you. Or, of course, you can look at where is y getting smaller, if that works for you as well. But I'm going to choose that 0, 0 point for those who would like to see that. If y equals 0, if x equals 0, 3 times 0 is 0. So is 0 less than or equal to 1? Yep, it is. So that means I'm shading this way and this way. Because again, I don't know at this point if I'm going to shade in this section or in this section. I haven't determined that. I need to figure out where the blue is going to. So when I do the blue, so again, you can go with the looking at here, where is y getting bigger? Up on this section or down on this section? Only looking at the blue line. Okay, is y getting bigger up here or is y getting bigger down here? But I'll go ahead and do that test point. So plugging in a 0, negative 2 times 0 is 0. Is 0 greater than 5? No. So I need to shade opposite. Same would be true, by the way, if you're looking at the y-axis, because this said greater than. Well, where is y getting bigger? Well, y is getting bigger here, not down here. So I'm definitely shading in this direction. So now I've got to look at where do they match up. Well, I can't shade in this section because that would be wrong for the pink line. I can't shade in this section because that would be wrong for the blue line. So the only section I can shade is this guy right here. So I'm going to shade it. Let's go with a green. I'm going to shade it here. This would be where you would shade, where they're both happy. You have to make both lines happy, both inequalities happy when you're doing this. Okay, so hopefully this helped, and we will work more on this in class on Friday.